Today, DJI Technology Company Limited, commonly known as DJI, commands over 90% of the global civilian drone market, standing unchallenged as the absolute leader in aerial technology. From Hollywood professional sets to casual vacation vlogs, DJI products define how the world captures aerial perspectives. However, the journey to global supremacy was anything but guaranteed. Back in 2008, the company was a tiny, debt-ridden basement startup on the brink of absolute financial collapse. This is the definitive story of how relentless engineering and bold leadership transformed a failing venture into a technological empire, and how those foundational lessons continue to shape cutting-edge consumer hardware. DJI was founded in 2006 by Wang Tao, Frank Wang, who left his university studies to focus entirely on building superior flight control systems for model aircraft. At the time, multi-rotor systems and drones were largely viewed as expensive, unreliable toys with very few practical, real-world applications. The financial struggle. DJI initially sold basic model helicopter components, but sales stagnated, market interest was low, and the company quickly fell deeply into debt. The lifeline. Survival only became possible when one of Wang Tao's early university mentors injected crucial angel investment capital, granting the startup a final window to pivot its core technology. The 2008 industrial breakthrough, DJI shifted its focus to high-end enterprise markets, releasing a specialized single-rotor unmanned helicopter priced at roughly $30,000. Though expensive, the platform offered unmatched capabilities for its era. It could carry heavy professional cinematic cameras, featured a stabilized mechanical gimbal for smooth video, transmitted live wireless video feeds, and executed fully autonomous waypoint missions. These features opened doors to high-value sectors such as professional filmmaking, infrastructure inspection, land surveying, and mapping. That same year, DJI proved its profound real-world utility during the devastating Sichuan earthquake in China. Wang Tao deployed DJI systems to capture over 1,000 vital aerial images of the disaster zones, enabling authorities to assess structural damage and coordinate rescue operations with unprecedented speed. Exhibiting this technology at major industrial exhibitions permanently erased the company's funding issues and secured its financial independence. With a stable financial footing established through industrial applications, Wang Tao made another pivotal decision, bringing professional-grade stabilization and aerial tech to everyday consumers worldwide. Mastering quadcopter mechanics. While competitors rushed to capitalize on the growing popularity of cheap quadcopters, which were easier to fly and more mechanically reliable than single-rotor helicopters, DJI took a methodical approach. Instead of releasing rush products, the company refined its advanced flight control algorithms, successfully adapting its stabilization software to 4, 6, and 8 propeller configurations. This engineering precision gave DJI a massive competitive edge, eliminating the erratic hovering issues that plagued rival brands. The Zenmuse Revolution, 2011. Entering the high-end filmmaking market, DJI introduced the Zenmuse Z15, the world's first high-precision brushless camera gimbal for civilian use. By utilizing 3 brushless motors to neutralize vibrations, it produced buttery-smooth professional footage at a fraction of the cost of traditional Hollywood helicopter setups. The Zenmuse generated thousands of orders and brought in hundreds of millions in revenue, cementing DJI's reputation for optical and mechanical excellence. The Phantom 1 breakthrough, 2013. The true consumer turning point arrived with the launch of the Phantom 1 in 2013. Priced at around $1,000, this ready-to-fly quadcopter could automatically hover, land safely, and carry a GoPro camera right out of the box. For the first time in history, everyday beginners could fly a high-quality camera drone without requiring professional training. The Phantom series democratized aerial photography, transforming DJI from a specialized component manufacturer into a household consumer electronics giant. The engineering discipline that saved DJI in 2008 lives on in its modern product development. Industry leaks and prototype tracking point to major generational leaps for DJI's upcoming ultra-compact line, such as the rumored DJI Neo series. Refined ergonomics and safety. Prototypes suggest a slimmed-down, open propeller guard architecture designed to maintain complete safety during palm launches while optimizing aerodynamic airflow and shedding bulky weight. Sub-250G compliance. Maintaining a takeoff weight under 250 grams ensures that casual users can benefit from simpler regulatory registration frameworks across major global markets. Cinematic optical leaps. Moving beyond basic selfie functionality, rumors point to larger physical sensors, 10-bit D-Log M color profiles, enhanced low-light processing, and high frame rate video options spanning from 4K per 60 frames per second up to slow motion 4K per 120 frames per second. Advanced transmission and FPV crossover. Potential integration of DJI's O4 transmission technology alongside compatibility with Goggle's N3 could allow users to seamlessly switch between standard line-of-sight flying and an immersive FPV experience. Multi-directional obstacle sensing. Upgraded sensor arrays are expected to provide comprehensive coverage around the aircraft, making tight indoor and outdoor navigation significantly safer for beginners. DJI's meteoric rise from a debt-ridden 2008 startup to a multi-billion-dollar global juggernaut was never a matter of luck. It was forged through strict engineering discipline, unwavering technical adaptation, and a refusal to follow short-term industry trends. Whether scaling up to professional cinema rigs or shrinking advanced computational photography and transmission technology into sub-250G pocket frames, DJI continues to redefine the boundaries of what is possible in the skies. Would you like to analyze how current sub-250G weight regulations and international compliance policies impact casual drone operators across different global regions?